Okay, so hi, good afternoon, everyone.
Good afternoon, sir.
Okay,
Good afternoon, sir.
okay. I think this is a recap of I think whatever calculus you have studied before. Possibly, I hope you have studied all of this in whichever is taught in week two in maths two, or maybe maths one. I don't know. Uh, yeah. So this is solve with us. Uh, Probably we'll start now. Uh, I think you know the drill, right? So you have to join through peer deck. So I'm just presenting your screen, my screen here. Just join to the peer deck. Okay. So
Okay, sir.
yeah. Okay. So my screen is visible, right? Yeah.
Yes, sir.
Okay. So use this code BWBAJA to join the peer deck. Yeah. I think I just seven students have joined, right? So yeah, use this code BWBAJA. So let's start this. Probably those who are joining, you can see this code on the top right of this screen. Fine. Okay. Um, okay. Yeah, this is the first question. The question is, let f of x be this function. If x is less than or equal to 0, you can have that portion of that function, right? So root of 9x to the power 4 plus x square divided by 5x square plus 3x plus 1 if x is less than or equal to 0. And if x is less than 0, I think there is a mistake. It should be if x is greater than 0, then the function will take value as x. So that mistake is there. Just ignore that mistake. And is f continuous at x equals to 0? That is the question. Take maybe 1 or 2 minutes to solve, and then we'll discuss the problem.
Sir, x is greater than
Yeah,
0,
yeah,
then
yeah.
it is x.
Yes, yes.
Oh,
How many sessions will there be per week? Okay, there are two mentor sessions, sorry, instructor sessions per week, and I think two TA sessions per week, right? So, and apart from that, mentor sessions are there, but yeah, those are only for those who are paid, right? Otherwise, in total, four sessions will be there.
so out of those four, one will be solved with us.
Yes,
Okay.
Sir, here we have to submit the answer.
peer deck. So you have to Google it, right? Uh, which is like peer deck. You can Google peer deck or joinpd.com, and then you have to write this code. So this joinpd.com is the website where you have to input this code. No space in between. There you have to submit the answers.
Okay, sir.
Yeah. Done?
Yes, sir.
Okay,
Yes, sir.
let me see the question. Okay, 9 of you have said yes, it is continuous at x equals to 0. So let me solve this problem. Okay. Yeah. So what is the function given to me?
Root 9x power 4 plus
It's root of 9x to the power 4 plus
X square
square
x cube
divided by
pi x square plus
5x
3x
square
plus 1.
plus 3x
5x
plus 1.
plus 3x plus 1.
okay, and that is when if x is
Less
less
than
than
Less
or equal
than
to
or
0.
equal
0,
to
and it is x when x
greater than
is
0.
greater than
X is
greater
0.
than
right.
0.
We have to find whether the function is continuous or not, and as per the definition of continuity, what we can say is that limit as x tends to that. Now here we are checking the continuity at this point, right? X equals to 0.
X is equal to
So
0.
we have to see that whether the left hand side limit at that point is equal to the right hand side limit,
0.
right? So here it is limit as x tends to 0. This part, what is it? 9x to the power 4 plus x square divided by 5x square plus 3x plus 1, and here it is the square root. It should be equal to limit as x tends to 0 x, right? And how you have to solve this? You have to plug in the value of x equals to 0 inside this function. And when I plug in there, what will happen to my numerator here on the left hand side? It will be
0.
0 by 0, right?
1. 0
Sir,
by 1.
0.
0 by 1. Okay, sorry. 0 by 1 because we have 1 in the denominator. And on the right hand side, if I plug in 0, it will be 0, right?
0.
That means what we can say is left hand side limit is equals to right hand side limit, and hence if this is true, then we can say that
Continuous.
the
It is
function is
continuous.
continuous. Okay, I hope this is fine to all of you.
Yes, sir.
Yes, sir.
Okay, so shall we move towards the next question?
Yes, sir.
Yeah. Okay, so this is the function for you. What it says is this will take the value of x square sine of 1 upon x plus 3 if x is not equals to 0, and it will take value at 1 when x is equals to 0, whether f is continuous at x equals to 0 or not. You have to follow the same procedure. Again, I'll give you 2 minutes and then we'll see the problem, see the answer.
Sir, answer for the previous question was yes, no?
Yes, yes, it is continuous.
Okay.
Yeah. While solving this, just one doubt.
Yeah.
How far these trigonometric functions are applicable for machine learning? Because machine learning, if you look at,
Huh.
my understanding is that it's more of general other algebra. So So do we really use, or will there
Yes,
be a use of trigonometric functions in machine learning?
It will be because see, if you say linear algebra also, right? What it is having is the vectors, right? You'll deal with the vectors if you understand the matrix and all this properly, right? In that also, how it is rotated, right? Inside the space, that also will be defined by your trigonometry. Moreover, there are certain functions. If you know the classification techniques and all, if you see machine learning, I'm not talking about the deep learning and other part. If you talk about the machine learning with respect to that, the logistic regression, which is one of the important or maybe fundamental algorithm for this classification technique, right? It uses that uh, this trigonometric functions, right? So it will be useful. So I will not say that it's not useful, but yeah, it is not very prominent throughout our machine learning journey. Mostly linear algebra part, the calculus in the sense whether the function is differentiable or not, continuous or not, right? All of differentiability, partial differentiation, integration, all of this will be the part throughout your understanding of the theoretical machine learning, right? Linear algebra and the calculus. Calculus is also very important. Probabilistic understanding of the, not calculus, I'm saying that statistics. So all the probabilistic understanding, Bayes theorem, everything will come up somewhere. So if you understand the machine learning through theoretical perspective, right, all these things will be very useful.
Yeah, I was thinking, I was thinking, other things like probability, linear algebra,
Yeah.
all fine, but
Yeah.
the trigonometric elements which is coming there, because they are more related to geometry, where angles, all those kind of things
Yes.
are involved. So where in machine learning they will be applied? I was just wondering. That was
Not like predominantly, right? That is correct. It's like you don't have to deal with like very rigorously with the trigonometric functions, but yeah, somewhere it might be useful, right? So you should understand those basics. That's it.
okay.
And
Thank you.
that's why this calculus part also, if you see, it's not very thorough, right? If you know like some mathematics, the mathematics books are there only on the calculus. Entire books will be there, right? We are not learning that much in detail.
No, my doubt was when I was trying to review this calculus part using NCRT, this 11th and 12th standard books, and in that books, if you look at
All the trigonometry is there.
it is more than 50% is trigonometry.
Yeah, it's a very vast field. It's
Yeah,
not,
yeah. So I used to wonder, should I do those exercises, or I just ignore them?
not required. Not required.
It
Not
is
required that
more of-
much.
more of getting fundamentals of
Yes.
calculus rather than trigonometry, because then
Yeah, no. That is like very deep mathematics. So
Ah.
I will not suggest to dive
Yeah.
into that. Right? If you have time, you can go
Yeah.
to it. But if you don't have, then I will not suggest it.
Yeah.
It's a very vast field. It's not like very easier, right?
Yeah. Thank you.
Yeah. So let's solve the question number 2. I saw the answers to this question. Like 13 are saying no and 1 is saying yes, right? So what is the function here? F of x is
X square
x square
sine 1 by x
sine of 1 by x
plus 3.
plus 3. This is when x
X
is
is
not
not
equal
Not equal to 0.
to 0 and 1 when
1
Equal to
x is
0.
equal to 0.
And the question which is asked to us is whether this function is continuous or not. We'll follow the same procedure as limit as x tends to which point? 0, right? X square sine of 1 upon x plus 3 equal to limit as x tends to 0. Yeah, so probably here we know that at x equals to 0 we are having this value, right? So it should be equal to, so this function should be equals to 1, right? Because left hand side of x is not equal to 0 is the same function, and the right hand side of it also is having the same function, right? At x equals to 0 point, it is having the value equals to 1. So yeah, here if I substitute 0, what will happen? I'll get 3, right? Probably sine of okay, so here it is sine of 1 upon 0. Okay, maybe I'll put it here. Sine of, what is sine of 1 upon 0? Infinity, right? Plus 3, right? Equals to 1. What is the answer to this? So 0 into something is 0, right? Whatever the value it is having, correct?
Yes, sir.
So the final answer is 3. So whether 3 is equals to 1? No.
No, sir.
And that means what? The function is
Not
not
continuous.
continuous.
Not continuous.
Not continuous at, this is important, at
X is equal to 0.
1. Oh, 0. Yeah, sorry, not 1. Correct. Okay, let's move to the next question, which is again similar kind of question. The only difference here is what? We have to find the value of c such that f of x, so we know that this function is continuous already. The function is given as minus x plus c when x is less than or equals to 1, and 6 minus 2x square if x is greater than 1. We know it is continuous at x equal to 1. Find the value of c. What you will do here? You'll compare the left hand side and right hand side limit, and they should be equals to, they should be equal, right? Why? Because this function is continuous at x equals to 1.
Where is the screen to enter the answer? I could not.
No, you have to join the joinperiod.com.
No, I did it already.
Okay. You don't have to enter. I think you just have to write.
Oh, okay. I find it.
It will got like submitted already, right? Yeah.
No, sir. We have to click on submit button.
Is it? Okay. I don't know. The previously it was not like that. I think it was just
Yes, sir.
the answer.
Now we have to submit. Click on submit button.
Okay. Previously, I think I'm like I have used it like long back, so okay, fine, no issues.
Hello.
Yes.
Yeah. Should we be expecting this level of questions in the exam as
Yeah.
well?
It will not be like very high level. It's like just understanding of what is calculus, right? Mostly you'll need, right, out of this you'll need mostly the partial differentiation, right? The gradient part is always be there because it's the optimization part, and it's just one of the important part of machine learning. So that part is very important. Otherwise it will not be that heavy.
Got it. And while we're actually programming and writing models and stuff, how far do we need these mathematical theories?
It will be there. So
Okay.
as far as your theoretical machine learning concerns, right, it is there. You can't escape it.
Whatever is being taught, it is required for machine learning and data science. That's why they have been selected.
Right.
To teach.
Okay, so mostly like MLT will be very theoretical. Then MLP you will be dealing with the this machine learning models through Python, right? So how to build the machine learning models through Python. So what we are doing here is in machine learning foundations and machine learning techniques, we are building the understanding of algorithms, right? Like all the algorithms which we know, supervised and unsupervised learnings, all will build about in a mathematical perspective. Once you build that perspective, then you will understand how this is working in the while you build the models using the Python or other languages, right? The programming languages. So that's the
MLT is also mathematical.
yeah,
Normally.
it is theoretical. So here in MLF, it's a recap of, I can say, your maths and stats, right? Whatever you learned until now, linear algebra, maybe optimization might be a new topic to you. Apart from that, stats also will have some new topics, but that's there. But MLT, you will have all the algorithms, like specific algorithms, linear regression, logistic regression, principal component analysis, uh, uh, other naive Bayes theorems, right? So all these algorithms which are there, right? Support vector machines. So like specific, it is algorithm wise. Like this is the algorithm, why it is used, what are the drawbacks and all. Right?
In MLT.
Yes, MLT, yes.
And we will implement in through Python in MLP.
MLP, yeah.
The project is in MLP.
Yes, project in MLP.
Okay, MLT is theoretical only.
Sure, yeah. MLT is theoretical, entirely mathematical. So you should be like, your foundation in linear algebra and statistics is very important there. Okay, so
Correct.
just be rigorous with your linear algebra part and the statistics part. Okay, yeah. So let us, can we say that? Can you just tell me what is the function? It's easier. I think all of you have found out.
Yes, minus x plus c. If
When
x is less than or is equal to 1.
Okay,
And 6 minus 2x square
6 minus 2x square when
if x is greater than 1.
x is greater than 1. So it's like similarly, limit as x tends to 1 minus x plus c. Since we know that this function is continuous at x equals to 1, it should be equal to limit as x tends to 1, 6 minus 2x square. If I plug in the values here, it will be minus 1 plus c equal to 6 minus 2, which is 4. So c will be equal to
5.
5. Yeah, most of you have answered it correctly. Not most, all. Okay, nice. So it's again the similar problem. Just try to solve it. It may be a variant of the previous one. What is the issue here? If I plug in the value of 3 there, what will happen? It will be a indeterminate form, right? 0 by 0.
Yeah.
So you have to use a L'Hopital rule.
Sir, the value of c will be in point is possible.
Yeah, if it is coming, but I don't think it is coming in decimals. But okay, whatever is the answer there. Uh, check it once. Like I don't think it is coming in decimals. Yeah, go ahead. What's who has raised hand? Okay. 7 of you has answered. Okay.
Come on. Hmm?
Okay. One more minute, maybe. You can just. Okay, shall I solve this then? Okay, now I can see
Yes, sir.
different answers. Fine. Question number 4, right? Can you tell me the function?
Yes, sir. X square minus 9 upon x minus 3 if x is less than 3.
Hmm.
Sir, not is equal to
That's okay. That's okay. That doesn't matter much. It's okay.
cx square
Hmm.
plus 10 if x is greater than or is equal to 3.
So what is the case? Limit as x tends to 3. So this will be left hand side limit. Generally they use this, right? Minus and plus. Not using it, but if you see somewhere in the books, they will use for left hand side minus and for right hand side limit as plus. 3 minus 3 plus, right? Okay. Equals to limit as x tends to 3. Why I can equate it? Because we know that it is continuous, right? Sorry, it is. So if I plug in the value of 3 here, what I get here? In the numerator is 0 and denominator is 0. And here
We can factorize it, no? X square by the.
we can factorize also, or we can use a L'Hopital rule. So both the things are fine. I'll just let you know how to do that. So it will be 9x plus, sorry, 9c plus 10.
9c plus 10.
So this is indeterminate form. So to avoid this, there are two ways. I can factorize the numerator. And what will be the factorization?
X minus 3x
X
plus
minus 3 x
X plus 3.
3 and divided by x minus 3, right?
Yeah.
And I can cancel it. And 9c plus 10.
Equal
So if I plug in 3, so it will be 6 equals to
to 9c
9c plus 10. So therefore, c equals to minus
Minus
4
4
by
by
9.
minus 4 upon
Yeah.
9.
Right,
minus
that should be the answer.
4, 4.
The another method which is widely used, which is L'Hopital rule. What is it? So when this kind of indeterminate forms, right? What are the indeterminate forms? 0 by 0, infinity by infinity,
L'Hospital rule.
right? So how you do it? You separately differentiate the numerator and the denominator with respect to that variable,
With respect to x.
right? So here it will be in the numerator, it will be 2x, right? So correct, right?
Yes,
X square
sir.
minus 9, what is the differentiation there? 2x. And in the denominator, it will be 1.
1.
1.
That means 2x equals to 9c plus 10. Now, if I plug in 3 here, what is the value? 6 equals to.
6 is equal to 9c plus 10.
And then again, it will give me the same value. Right? Okay. I hope this is clear.
Yes, sir.
Let's
Yeah.
move forward.
In the L'Hopital rule, we differentiate
Numerator and the
both.
denominator separately.
Only that part.
Yeah. Where you find this indeterminate form, it's called indeterminate form.
Okay, where 0 by 0 form is there, right?
0 by 0, infinity by infinity. I think 0 into infinity. I think this
Infinity
is
minus infinity,
infinity minus infinity. All of these are
infinity
the
to the power of 0, 1 to the power of
infinity power 0. 1 to the power infinity is not there. I guess it's not there.
that's also because
1 to the power infinity is 1, right? What?
1 to the
Yeah,
power
1 to
infinity. Anything other than
That's
infinity is 1.
in
I don't
I
know.
think
indeterminate
these
form, which
these
is
are
done
the
on
these are the
taking.
indeterminate means there is no
Yeah.
uh,
0 to the power of 0.
yeah, right. So okay, so you can find it out, like that's like all of these things are there. You can anyway find it out. Okay, so yeah, find all values of x where g is not continuous. So you have to find out the values, write your values by comma separation, comma separated values. This is the function. So when x is less than or equals to minus 1, 1 upon x plus 3 square. Between x is between minus 1 to plus 1, it is 2 minus x. And when x is greater than 1, 3 upon x plus 2. We have to find the values where x is not continuous. And yeah, you just go ahead. I'll let you know where it is not continuous.
Sir, can you show a little bit that in solution of previous question?
Previous question, yeah. So this is second method probably.
So
Here I have,
yes, sir.
yeah.
So how sir 2 came, sir? 2x.
Huh? See, I have differentiated this part. So what is the differentiation of this part, the numerator, with respect to x? 2x. And
2x, yeah.
differentiation of the denominator is what? 1.
Only
Right?
one.
So that means 2x.
Yes, sir.
And that's how I got 2x. And then I have substituted
And yeah,
3 here. So I'll get 6. Fine, right?
and sir, we do not need to do differentiate in right hand side.
No, because there is no this form, na? This we can do when we have this kind of forms. So here, if I plug in 3 here, right? What happened here? So 3 square is 9, 9 minus 9 is 0, divided by 3 minus 3, right? So it is 0 by 0. When we have this kind of 0 by 0 form, then only we can do that. Understand? Here it's not like
Yes,
that, na?
sir.
On the right hand side, I just have to plug in. So it
Yeah.
is 9c plus 10. So some values there, we know that. We don't have to do on the left hand side. Fine. Oh, sorry, right hand side.
Okay, sir.
Sir, -3 and -1.
Minus, yeah, I have to check. I don't know the answer. We'll do that in 1 minute. Okay, let us see now. Okay, varied answers are there. Fine. Okay, can you just tell me what is the function? F of x equals to 1 upon x plus 3 square.
If x is
Less than
X
minus
is
if x is
1.
less than
Then
or
equal to
equal
minus 1.
2 minus
2
x.
minus x, if -1 to
Equal to
1
1.
also.
Okay. Generally, it doesn't affect much.
3 upon x plus 2
X plus 2
X is
minus
more
x.
than 1.
if x is greater than 1.
Not equal to.
Okay. So we have to find out the values where it is not continuous. So let us see first at -1. So we have to check for this values, right? So what is the limit here? The limit as x tends to -1, 1 upon x plus 3 square equals to limit as x tends to -1, 2 minus x, right? If I do that, what is the value? So x is -1 plus 3. How much? 2. So 2 square is 1 by 4
1 by 4.
equals to 2 minus of -1, which is
3.
so that means this value is not equal, and hence g is not continuous at x equals to -1. Right?
-1.
Now we have to check to these values. So what is that? It is limit as x tends to 1, right? X tends to 1, 2 minus x equals to limit as x tends to 1, 3 upon x plus 2. So again, if I substitute 1 here, what is the value? 1 on the left hand side limit.
1 is equal to 1.
So therefore g is continuous at x equals to 1. Okay, what else it can be not continuous? Where it can be not continuous? Can you just tell me apart from these values? So if you look at this function, right, when this function will not be continuous, when the
Denominator is 0.
determinant is 0, right? And at what value you can say that it is
Minus
possible?
3.
-3.
Because this function is x plus 3 whole square. When denominator is 0, what will happen? It will become infinity. That means this function g will not be defined. So g is not defined at that point, right? At that point. But when it will be possible? When x is equals to -3. So will this be this point will be a part of that domain of G? It is, right, because we have this function when x is less than or equals to -1. So we can say that at x equals to -3, G is not defined, right? not defined, and hence it is not continuous at x equals to -3. Is this the same case here? So when this function will go to infinity,
-2.
so 3 upon x plus 2. So this function will go to infinity when your denominator will become 0, and denominator will become 0 when x equals to -2. But here,
Not in range.
this function is
More
defined
than
for
equal to 1.
1, right? So the x equals to -2
So
will not be in
it's
that.
not true.
Yeah. Yes, yes,
So-
please.
X is greater than 1, only then it is x
Yeah,
upon
yeah.
x
So this is
three
not
upon
possible, no?
x.
So x equals to
So
minus.
that is not there.
So that means this is not the part.
No,
So
that is not the condition.
correct, correct. So where at what points it is not continuous? So g is
-3
not continuous
at
at
-3 and -1,
-1 and -3.
-3.
So that should be your answer.
Yeah.
Why
So
don't-
this, yeah.
Yeah.
So one doubt.
Yeah, yeah.
So
Please.
when we have such a problem, how do we, look for the values? One was, see, the transition of
Correct,
this
correct.
formula
Please come.
was at 1 and
Yeah.
-1. So
Yeah.
we look for that. So
And
other
here-
scenarios, we look for possibilities where the
Infinity. This
limit
function
is
will go
not
to
defined.
infinity. Yes.
Okay. Thank
Right. So that is the only part. Okay.
Okay.
And sir, one more can be a case where it is given a root, under root, square root, or
So
something.
square root, when it will go infinity? No, no, it is not like that, right?
No, it should be defined, na, that the
Ah.
terms inside it should be all constitutes to be
Greater than
positive.
0.
Yeah, positive.
It should not be a complex number.
Yeah, yeah, okay.
Minus
Yeah, yeah. That's it.
square root of minus something.
Correct, correct. Fine. Okay. What is the approximate value of root of 9.1? So this problem will be solved using linear approximation method, right? What is it called? Linear approximation, right? Only. Yeah.
Yes.
Yeah, yes, sir.
Maybe I'll just define it for you. Those if you forget the formula, it is. I think it is. So generally, your Taylor
question-
series is like this, no? Just a minute. Your
So the
Taylor.
question-
1 minute, 1 minute. I'll finish it this thing off and then we'll start. So what is your Taylor series? Basically, it is f of x plus h is f of x plus h into f dash of x plus h square into f double dash of x, right? And by 2 factorial h cube upon 3 factorial f triple dash of x and so on. But for linear approximation, we'll consider only these terms, right?
First term.
First,
First two terms.
yeah, and we'll approximate f of x as, what is it then? F of x plus h
Plus h.
minus h into f dash of x. So basically your h is what? A smaller interval, right? And I think that is your linear approximation. What do you do for quadratic? We'll have to include this term, but yeah, that is not there correctly, I guess. But yeah, this is fine. Yeah, what is your question now? You have to use this.
Sir, I want to write the question.
Done, sir.
Done, sir.
Okay, let us see. Okay, almost everyone has done it correctly. Let us see the answer. How to do that? You have to find out the linear approximation of root of 9.1. Right. So I can write this root of 9.1 as root of possibly 9 plus 0.1, right?
Yes, sir.
So the function here is root, right? So f of 9 plus 0.1, something like that, right? How to do this? How to solve this then? We need the approximation here. Basically, I can actually use it, let's say, yeah, is approximately equal to okay, what is first place? What is the function here?
So,
Root of x, right?
so if we take 9 as x and 0.01 as h.
That way also you can do it. So basically it will be added, no? So f of x is root of x here. So f dash of x will be
1 by 2 root
1 upon
x.
2 root x.
Root x.
So if I use this, then what it will be then? F of x will be f of
3.
9, right?
Plus
uh,
0.1 into
0.1 into f dash of
X.
x. X is what is
1
here?
by 6. 1 by 6. F dash x is
F dash of 9, right? That correct?
Yes.
Right. So f of 9 is, like, let's say root of 9 plus 0.1 into 1 upon 2
2
root.
root 9.
2 root 9.
So here x is the function.
The function here is root, na? Root of x. X
root
is the
of x.
value.
What is x here?
9.
Then the
This
function should be
Root of
function
9 will be
of
3.
x plus h, no? So x is
Yeah,
9. Right? You're understanding it? This part.
Yes, sir.
So root of 9 is 3
3
3
plus 0.1
plus point
by 6.
divided by 6. So
6.
f of x should be 9.1, no?
X is
X.
9.
see,
No.
here what you actually you are finding out the value of this. Okay, maybe I'll just reconstruct this part for your understanding. X is f of x is actually the known value, right? So which
The
is
formula.
so let us say this Taylor series, right? You can use only this part,
Yeah.
right? So it is f of x plus
Because
h,
it is linear approximation.
right? So we are why I'm not equating it, because we are neglecting these terms, right? We are neglecting these terms, so it will be approximately equal to f of x plus h of f dash of x. So x here will be 9. So we are using this part, right? So here x will be 9 and h will be that small interval, which is 0.1. Fine.
Yeah.
So this is 3 plus 6. 0.1 by 6 is how much? 10 by 6 almost, right? So it's like 0.01 6
6, 7.
something. Yeah, it is
0167.
3.067. This is the
Up to 4 decimal points.
that is the value for 101.
9.1. 9.1.
1, huh? Okay, sorry.
Hello, sir.
Correct. 9.1. Here also I did the mistake, right? I guess. 1. Right? Okay.
Yes, sir. Sir, I am not getting one thing, sir.
Yeah, tell me.
Like, can you scroll up a little bit? Yeah. So, sir, here you have given 9.1. F of 9.1 is equal to f of 9. And you have converted into two part of
Okay.
one value, isn't it, sir?
Just a minute, I'll tell you. Do you understand this part? This part? F of x plus h. X is what? 9, right?
9.
Yes.
And h is that interval where actually you are wanted to see that, right? Now if I'm using this formula, what is it? F of x plus h equal to f of x plus h into f dash of x, right? So what if I substitute here, it is 9 plus 0.1, right? This. So how much it is?
Yes, sir.
9.1
Yes.
equal to f of x means f of h. X is what? What is the
F
value
of
of
9
9 plus h is 0.1
is 0.1.
and f dash of 9, right? What is the
Yes, sir.
function here?
Yeah.
What is the function here? Root of x, right?
Yes, sir.
Yes, sir.
And f dash of x is 1 upon 2 root x. So wherever x is there, I will substitute the value of 9, and wherever h is there, I will substitute the value of 0.1. That is what I have done here, right? So are you able to now understand this part?
So now, so you are, yeah, 3. Oh, yes, sir. Got it. Yes, sir.
Okay, this part.
Yes, sir. Got it. Yes, sir.
Okay.
Yeah.
Okay, so let's move ahead. Find the linearization of cube root of x at x equals 2. Same linear approximation problem. What is the function here? Cube root of x, right? And we wanted to find the linear form of like linear approximation form of cube root of x at x equals to 8. Maybe I'll solve this one. Okay, I'll do this part for you. I need to find the linear approximation. So what is the function here? F of x is cube root of x. I can write this cube root of x as x to the power 1 by 3, right? All of you are familiar with this?
Yes, sir.
Yes, sir.
Okay, and we have to
Yes, sir.
find out the linear approximation or linearization. Both are the same terms. Approximation at x equals to 8. Okay. So basically, I wanted to find f of x plus h is nearly equal to f of x plus h into f dash of x. What is f dash of x?
1
Is
by
1 by
3 x
3
to the
x
power
to the
minus 2 by 3.
minus 2 by 3, right? This is okay? Or in other words, I can just write it like this: 1 upon 3 cube root of x square. Is that okay? This is fine. If you don't understand this part, it's okay. You can just like write down like this. Then I need to find the linearization. So it will be f of x plus h equal to, what is f of x? X to the power 1 by 3 plus h into 1 by 3 x to the power minus 2 by 3, right? I need the linearization around 8. So x will be what? 8, right?
8.
So 8 plus h is equals to 8 to the power 1 by 3 plus h 1 by 3 x to the power, x is like 8 to the power minus 2 by 3. And what is cube root of 8?
2.
2
2.
plus h, let's say h by 3. First, how to solve this, right? So I can just understand this as 1 upon
2 to
8
the
square
power
cube root, right? So what is 8 square?
64.
64.
64.
And what is the cube root of 64? 4.
4.
4.
So 2 plus h by 3 into 4. So this this part, right? It is equals to 4. So 4 into 3 is 12.
12.
12. Right. So then I can say that f of x plus h, which is 8 plus h, is 2 plus h by 12. Right?
Yes.
And that is your linearization around it. So this is linear approximation around x equals to 8. Right? Linear approximation of what? Okay, maybe I'll write down of this function around 8. Right now?
Sir, where we will use linear approximation, sir?
Huh?
Linear approximation, where it will be useful for us in this? Like
Where it
function,
is
we have the differentiation and integration. Those things are like directly we can do.
Huh.
If where we will using this linear
optimization. Okay.
Suppose we want to find out the linear approximation of some value around 8. Suppose 8.0 to 8.3.
Just you have to, let's say 8.3, right? So you just have to put here. So f of 8.3 will be approximately equal to 2 plus 0.3 by 12. Now this is a generic form, right?
That's what I'm asking. Generic form. If it is 7.9, if it is
7.9,
7.9, then we will find 0.1.
Yeah, 8
minus 0.1.
Yeah, that's right. That's correct.
We can use directly and use it also.
Yeah.
In the real life also, no?
Yeah. Everywhere we can use it.
Yeah. Okay. A general formula.
Yeah. But it is only around 8, no?
Yeah. The condition is that it is around 8.
Yes. Now, so I have already showed you, right, how to find it out. Now you find it out for this. Compute the linear approximation of f of x, which is 1 plus x to the power n around at x equals to 0. So this is wrong. Okay, it shouldn't be at x equals to 0. It should be around x equals to 0. So
to the power n.
sorry.
To the power n.
You write your answer. I'll just cross check. I don't know what is the answer.
No,
so
no, it is the function is 1 plus x to the
acha,
power n.
Yeah, 1 plus x to the power n. Yes.
Okay.
Please don't speak. Otherwise, please unmute yourself if some noise is there. Okay, so shall I solve this now? Okay, I'll solve this.
Just wait.
Sir, 1 minute.
Okay. Is it done?
Yes, sir.
Yes, sir.
Okay. So let me solve this. So your function is f of x plus, or maybe I can just say what is f of x is 1 plus x to the power n. And we have to find out the linear approximation around x equals to 0, right? So for that I need f dash of x. What is f dash of x? N into 1 plus x to the power n minus 1.
N minus 1.
Right. And if I use this here, what is it should be equals to f of x, which is 1 plus x to the power n plus h into n 1 plus x to the power n minus 1. But we need to find it around x equals to 0. So I'll use 0 plus h. It is 1 plus 0 is how much? 1. 1 to the power 1, n is 1 plus n into h, and here again 1. So it will be n h. So your approximation, right? So I think it is called as Lx star, right? Something in the class. So
Yes.
1 plus nh. This is linear approximation. It is around x equals to 0. So this should be your correct answer. Okay, let's move forward. Okay, I'll just write it down maybe. What it should be, can you just tell me? I need to find out the linear approximation of f of x.
H, there h is coming. H is a very small number, right? Suppose the approximation is being asked, then h will be presumed that the approximation will be in the terms of h.
Yeah, but here if you see that it is 1.01, so you have to find out the linear approximation again. Around which point?
0.01.
Just
H,
look at it.
Here will be 0.01 h, right?
No, but here it is x is 1, right? It's not 0, right?
X is 1. Around what you want?
First of all, you have to find out the linear approximation of the previous that term around 1. What you have, this is around 0, right?
Yeah.
So what you have to do here again, you just have to find out around 1. So here this step you have to do f of 1 plus 1.01 equals to what is it? 1
power
plus
n.
1. So which is
2 power n.
2 power n plus h into n, and here 2 to the power n minus
1.
N minus 1.
And this is the approximation around, is around
1.
Around 1. Now you have to use this approximation to find out the answer. And what is n here? Equal to
3.
How this 2 to the power n came? 1.
Okay. So this is your 1 plus x to the power n, right? This is the function. Is that correct?
Yeah.
Okay. Maybe I'll just write it down again for you.
Both are 2 questions or 1 question?
Different question.
Different question.
So 1 plus x to the power n, right? I need to find out the linear approximation around 1. So what it should be?
Previously it was 0.
Yes. So around 1 it will be f of x plus h into f dash of x, right? And this is around 1. So when I say 1 plus h is f of 1 plus h into f dash of 1. What is f of 1?
This is 2 to the
power n plus h. And what is f dash of x? F dash of x is n into 1 plus x to the power, sorry, n into x to the power n minus 1. So what will be f dash of 1? hn into 2 to the power
n minus 1.
n minus 1.
Minus 1.
Right. Now this is the linear approximation around x equals to 1. Right? And now what I wanted to find f of 1.01. So now it will be, and what is n here?
3.
3.
N is 3, right? The exponent is 3. So 2 to the power 3 plus h is how much?
0.01.
0.1, right? This is h into 3, and 2 to the power 3 minus 1, 2. So if I solve this, it is 8 plus 0.1 into 12.
Sir, h is 0.01.
0. Yes, correct.
01.
Correct, sorry. 0.
8.12.
It's done 8 point. So it is 0.12. Then it is 8.12. F of 0.01. I hope this is okay.
Yes, sir.
Right.
Just one
Okay.
doubt.
Yes.
Hello?
Yeah.
Just one doubt. See, he's asking for f of 1.01 to the power of 3. Only thing is, we are telling that in the previous question x was something was there, and so somehow at the end of the day, you are trying to figure out what is 2.01 to the power of 3. Even though in question it is f of 1.01. So we are assuming that there is an additional 1 there, right? If you see that,
Yeah.
0.12, it
Correct.
is actually something close to the 2.01 to the power of 3, not 1.01 to the power of 3.
So if you use that also, right? So if you use 0 also, that will work, but it will give it will not be correct approximation. Why, I'll tell you. So you know the function y equal to x square, right? Let us say your function is f of x equals to x square, right? How this will look like on the graph? It will look, it is a parabola, right? Sorry, this parabola is some parabola, right? So if I ask you that, let us say I wanted to find a linear approximation at, let's say, at some point, this is, let's say, x equals to 2. Okay, what is the linear approximation means? So basically it's a line, right, which goes through this point. It will touch this point, right? It is tangent to that point, if I say, right? And when I say linear approximation means, you are, let's say you wanted to find the function's value. Okay, maybe I'll just write. Sorry. Maybe I'll just draw like a little bit like this. So when we find out the approximate function's value at, let's say, this point, or this point, right? What is the approximate value if I use it around this point? This is the function's value, right?
Oh.
So there is a difference of this. That's why we say approximate value. But if I say around x equals to 2, if I use this approximation to find the value of, let's say, at x equal to 6, and if I plot it here, actual value is somewhere here, right? Function's value, correct?
Yeah.
But with the approximation, you will get this value. Is that right? This is some approximate value using the approximation here, but actual value should be here, right?
Yes.
You're understanding the point.
Yeah,
So if I for finding out f of x equals to 6, right, I should use the approximation around
2.
X equal to 6, right? Or let's say x, I'm just saying that's 6.01. Let's say it is 2.01. Correct, no?
Yeah. So you identified using x is equal to 2.
Because approximation.
Extrapolating it.
Correct.
That is what we are doing.
Yes.
That's why when you are asked, function of 1.01 to the power of 3, we are computing the,
if you use correct. So if you use 0, right, this approximation, this will also work. But will that give you the closer value? So h will be using what for 1.01? 1.01, right? And that will be giving me 1 plus 3 into 1.01. So how much it is?
4.03.
4.03. But this value is like far off, right? So that's why. Yeah. Okay.
Apologies for keeping wasting others' time.
In the Taylor series, x should be very, very less than the x. That's why
yes,
it will be
x correct.
This is the condition of the Taylor series.
Correct.
H must be very less
Small
than
interval.
the
Small interval.
Yes,
But for the
very
previous,
small.
but for the previous question, they were asking 1.01 whole cube, isn't it?
Yeah.
Then how it can be 8 point something?
Yeah, that is what I was also coming, but there was
so.
But there was an assumption that x is 1, so 1.01 will become 2.01.
Any case, it will be basically 1 plus nx, na? So it should be 1 plus 3 into 0.01. So it should be 1.03.
Sorry. I just missed it.
A question asked was 1.01 whole cube. That's the approximation being asked. In that case, this 2 cube should be 1 cube, and so that is what we are saying.
But
He's right. He's right. He's telling right.
Yeah, that is okay.
X is 1 here. X is not 2, na?
It should be 1 basically, because 1.01 whole cube. So what you have taken is, I think, 2.012 whole cube.
But the function.
No. Whole cube.
Okay, we have to use this one, right? This.
Yeah, right.
So if I use this, then what should I do?
So it should be 1 plus nx. Lx will be 1 plus nx.
No, correct. It will be 2. But how can we accept it? The approximation of 1.01 to the cube is equal to
it's like it will not give you the correct values, right? That is, but yeah, I think
question was, sir, 1.01 whole cube, na?
Correct. Yeah, sorry, I understand the point. Okay, what we have missed here is correct. So this should not be the correct answer.
Yeah, this answer is not acceptable.
It's not like acceptable, but the thing is 1 plus x is totally it's 1.01. So yeah, that is the correct. Okay, sorry. I think I should.
Total value is 1.01.
We wanted to find. Okay, so in that case, okay, I got it. So we have asked to find out the value of 1.01 to the power n, right?
Yes.
Or 3, let's say 3. So here n equals to 3 and x should be equals to
0.01.
0.01.
So it should be 1 plus 0.03. That is 1.03.
So we can use this approximation.
Yes.
Because around x equals to 0, that is 0.01.
Yes.
And then the answer should be 1 plus 3.
1 plus 0.03.
Yeah, so that is 1.03. Correct. Right. So all of you understand, right? So I think I just missed that part. Like I just taken it 1 plus x to the power.
Sir, I couldn't get it. Why we are using approximation at x is equal to 0?
Yeah. So because our function was what? It was 1 plus x to the power n, right? And we have asked a value of what? Let us say f of x plus h. That value is how much? 1.01, right? Or maybe we were finding out this value, right? F of 1.01. Correct?
Yes, sir.
So if you just compare these two things, right? So it will be 1 plus x equal to 1.01. So here x is equals to actually 0.01, right?
Yes, sir.
And that is around x equal to 0. It's 1 is already there, na? It's cumulative value, right? 1 plus something. You're understanding the point or no?
Yes, sir. Got it.
Yes, sir.
And that's why we have to use the linear approximation at x equals to 0, and that is what that is how much it is 1 plus nh we have found out, right? So 1 plus 3 into 0.01, and that is 1.03. That is technically correct, right? So okay, let's move ahead. We have done this. Find the linearization of f of x equal to e to the power x sine of x minus y at the point 0, 0. So in this question, what it should be? This is two-dimensional, right? So how this will change?
Partial derivative.
Yeah, partial derivative we have to use. So basically, this will be the same thing, which is f of, let us say, x. Maybe I'll write down v here, right, for vector, plus h into here it should be not, it should be del of f at v, right? This is gradient. Is that
So why gradient?
because we are dealing with the vectors, na? So we will have two values, right? Maybe x.
Can you show the question once again? So you missed the question.
Yeah. No, I'm just giving you the hint. So maybe once you've done the solving, then I'll solve it.
Sir, could you please show the formula?
No, same formula you have to use. The only thing is gradient. You know how to solve, how to find out, right?
Yes, sir.
What is it? How to do that? Del f will be del f by del x, del f by del y. It's a vector with the values, right? V. Solve it. I'll let you know how to solve it. Shall I solve this? Or okay, are you guys doing it, or shall I solve this?
Sir, 1 minute.
Okay, fine.
So we have to take the
Done.
differential of both sides and then equate it to 0, right, sir? To
No,
solve it.
same thing which we have done earlier. We don't have to do like anything different. The same thing we used for the linearization of the single point, like scalar, right? Here it's vector.
Okay, sir. I will see the solution first.
Okay. Shall I solve this now?
Yes, sir.
Sure, sir.
Yes, sir.
Okay, so we have our function as what? Is a function f of, I'll say that, let's say if it's a function of xy, right? And that is e to the power x sine of x minus y. I need a gradient to solve this. So what is the gradient here? Del f is, it can be written as in the vector format. It is del f by del x, del f by del y, which is a partial derivative of function f with respect to x and with respect to y. So what is the partial derivative with respect to x here? It is e to the power x. So what is the derivative of e to the power x? E to the power x, and sine of x minus y. Shall we treat it as constant or no? No, right? The derivative of, so basically it is you can consider this as u and this is v. So what is the differentiation of u and v? It is u dv plus or minus
Plus.
v du. So dv by dx, right, and du by dx, for example. So here, let's say if I treat e to the power x constant, then sine of x minus y is cos of x minus y, and again we have to differentiate this x, so it is 1, right? Plus v is what? Maybe okay, I'll write down here bottom. So this will be u is here, u I'll treat as e to the power x and v sine of x minus y. And with respect, if we use the above formula, it will be e to the power x. Then what is this? Cos of x minus y, and differentiation of x minus y with respect to x is 1, plus e to the power x sine of x minus y. Okay. And what about with respect to y? It is e to the power x
Cos x minus
cos of
y
x minus y and
minus 1.
So basically this will become minus e to the power xy. Okay. And now what are the values? At what points we have to see? At 0, 0. So by substituting the value, so I'll get del f at, let's say, 0, 0 as e to the power 0 is 1.
Sir, here we have also need to do now u into v.
No, here because e to the power x is free from y, right?
Yes, sir.
You have to treat when you differentiate with respect to y, then whatever the functions of x are there, we treat them as constants, right? So here actually it's a constant e to the power x, so we don't have to worry about it. Is that right?
Okay, sir.
So now if I substitute the values 0 here, so e to the power 0 is 1, cos of 0 is 1 here also. So sine of 0 is 0, right? So basically you will get 1 here, and here minus 1.
Minus 1.
Cos of 0 is 1 and e to the power 0 is 1. So you'll get minus 1. So this gradient is 1 minus 1, right? Okay. We have found out whatever required things are there. Now we'll use the approximation. We have to find out the linear approximation. So linear approximation at x plus h and let's say y plus h, or whatever other values there, let's say h prime, equal to, or is it equal to f of xy plus h, or I'll say that x plus h and y plus h prime, sorry, not h, right. This will be h and h prime only, right, into del f at xy. So this will be what? F of xy is how much? So this is your function, right? F of xy. So f of 0, 0 is how much?
0.
0.
0, right? Okay. Then this will be 0 plus, basically you have to take a transpose, right? So then only you'll get some scalar value. Basically this is transpose.
Gradient of f0, 0 equals to 1 minus 1. That is with the solution, or that is the solved value, or how did we get it?
We have substituted 0, 0, na? Gradient at 0, 0.
Okay, so that will be 1 and minus 1.
Correct. And here you have to do I think h, this value transposed del f, right? That's correct. And this is h plus h prime minus, so minus h. What is, I don't know what is in the lectures are there. I don't know whether it is used as like this or something else. I'm not sure. But if it is not there, what was your values here? What you found out? X minus y. Okay, h minus h is fine. This h prime basically.
Sir, could you please explain from last third line?
Okay. First of all, what are the familiar? Okay, just give me a minute. Maybe I'll just talk to you about from the familiar perspective. What is used in the lectures, right? I'll use that same notations maybe because this might confuse you. Just give me a minute. What are the notations? It is same as that of this one. What is it? Linear approximation, how it is used. Okay, so I'll write down again, right? So let's say v is a vector. Fine. What is it denotes? Values of x and y, right? Suppose here, and here v is in how many dimensions? 2 dimensions, right? R2.
Yes.
Now,
yes, sir.
F of, let's say v, this is, let's say this is a linear approximation of that, or I'll say that, let's say L of v. What is L of v? Basically it is linear approximation, and that can be written as f of v plus del f into or del f at v transpose, let's say, maybe I'll say that this vector x minus v.
Yeah, this is what they've used in lectures.
Right. Yeah. Okay. So yeah, correct. I think this is what it is used, but it's again the same thing. I'll tell you how. What is f of and what is v in our question? 0, 0, right? Correct. What is f of x, y? It is e to the power x sine of
X minus y.
y. Okay. What is the gradient of f at xy? Or a gradient of f is what? Basically, it is del x, del f, del x. It's a vector. Correct. And if you have 3 dimensions, then it will become like it will increase, right? So it will become del f, del x, del f by del x, del f by del y, and del
V
f by
is the point now where we want
v
to
is the point, right?
Where we want the linearization. V is the point.
Right. So basically, previously when we said that around x equal to 0, right? The linear approximation at x equal to 0. Now we are saying that linear approximation around this vector 0, 0, right? Fine. So now this is what we have found out here. This is fine, right? This part. I'm not going to write it again. This
Yes, sir.
And at 0, 0, what is the value of this? It's 1 minus 1. I hope this is clear till this part. Okay?
Yes, sir.
So linear approximation at this point v is what? It is equal to f of v. So what is the value of f of v? V is 0, 0. So f of v is what? 0.
0.
Correct, na?
Yeah, sine of 0 is 0.
So here it is 0 plus del f v transpose. So transpose of this vector.
Row vector.
So this is 1 minus 1 into x minus
0.
0, y minus
0.
This is transpose of the gradient, no?
Yes, this is the del f transpose, which is the gradient transpose. And at
transpose of the gradient at 0, 0.
That point, yes.
Correct.
Correct.
And
this is x minus v is x minus v and y minus v. So or basically what it is, I think it is written like this, no? Is v1 or v2, maybe you can consider. These are the points, like let's say v, when I'm saying v, basically it's also a vector of how to write it down. I don't know what is the notation for this, but
They have used y1 minus v1 and y2 minus
something
v2.
like that, sir.
Like that. Yes.
So you can so here it is x minus 0 and y minus 0 basically, right? Because this function should be
go scroll up once again the formula. This is scroll up xi minus vi.
Basically you can say that it is like that. You don't have to like x minus v, but with ka x component.
Yeah,
right? And minus v minus y component, like that.
Correct. It is like that.
And then you can solve it. So it is 0 because it's a scalar, right? And this also should be, this multiplication also should be a scalar quantity, correct? This vector is 1 cross 2, 1, right? And this vector is 2 cross 1. So the multiplication will produce what? A scalar quantity.
1 cross 1, yeah.
Right. And that is what it is: x plus x minus y. So basically the linear approximation of that is x minus y. And this is the linear approximation of what? E to the power x sine of x minus y of or around xy equal to 0, 0. Is that okay?
Yes, sir.
Okay, so this can be viewed actually differently also, but okay, that's I don't. So if you go with the different notation, I think it will get I don't know, confusing. But I think this is fine. Okay. So what should be the answer? The final answer?
X minus y.
Yeah. Okay. Compute the derivative of f of xy, which is x to the power. So it is actually x square y. Okay. X square y. This is the function of xy is a function x square y. We have to find out the derivative in the direction of 1 comma 2 at the point 3 comma 2. This is a directional derivative problem. It's your function x square y. Now let's do it faster. Okay, so we are like going very slow, so maybe just do it fast. I'll give you 2 minutes, and after that I'll solve it.
Sir, is this session recorded?
Yes, YouTube link you can see at in the calendar itself. I have attached there.
Okay, thank you, sir.
Sir, will the solution be provided in the supplementary content?
No, this solve with the slides will be provided. Solution, I don't know.
Okay, sir. Solve with slide. Where can we find it?
Under supplementary content, you can see that solve with the slides. So I think week 1 is not also shared with you, right? Or is it shared? If it is not, I'll share both of that.
Not shared in the supplementary content.
Yeah, we'll share.
Okay.
Sir, can you please also upload these slides, like where you're writing?
Those are like,
The
they are not that good, right? So I don't know what to do with that. This is like, I'm just writing it. Later on, I don't know. Maybe this few questions above there, but still it's like everywhere, right? I don't know. If you need it, I'll share it, but I don't think they are very good slides.
So please share.
Okay. I will attach this handwritten things, right, in the calendar itself with the today's. Yes.
Okay, sir.
Yeah.
How many more questions are there, sir?
I think 3-4 are there. So if you just do it faster, I'll finish it as.
Sir, please discuss.
Yeah. Okay. So is it okay if I'll solve those? So maybe what is it? This is a function, and we have to find the directional derivative in this direction at this point, right? Okay. What is the directional derivative? So I'll write it as dd. Basically, it is del f, right? And del f into, let's say, at this point, right? So if I'm just saying that this point is 3, 2, point is 3, 2, or we can write this point as a vector. If you want to write, this is 3, 2, and in the direction, let's say
1, 2.
U is, what is it? 1, 2.
1, 2.
1, 2, or yeah, 1, 2 if you say. So del F at V transpose into U, right? Basically, U is in this direction. We have to take the unit direction, right? So first of all, let's try to find out the del F. So del F will be what? Is del F by del X. Why? Please don't make the noises. Right. So at 3, 2. What is the gradient here? Del F by del X is how much?
2xy.
2xy.
And
Del F by del Y is
X square.
And at point 3, 2.
3, 2.
So what are the values?
12, 9.
9.
12
9.
9.
9.
Okay. So this is my vector. And the direction given to me is 1, 2. But we need the unit direction, right? So unit direction means what? We have to find out the length of that vector and divide it by, right? So we have to normalize that. So what is the length of this? So it is a L2 norm, basically.
Root 5.
1 by root 5.
Root of 1 square plus 2 square is root of 5. So the direction will be, or I will say that unit direction will be, it is 1 by root 5 and 2 by 5. Okay, this is the direction. Now the directional derivative is del F transpose. What is del F at 3, 2? 12, 9, right?
12, 9.
12, 9 into.
It will be 12, 9 or 12, 4?
9, right?
9.
Just
So
take
x
up
square.
y.
X square. 3 square, right? This is
No,
3, 2.
X square. X is 3. Okay, fine.
Right, na? 1 by root 5, and here it is 2 by root 5. So the dot product between these two will give me what?
This 12, 9 is the gradient of del F is the gradient, no?
Yes, this is
12,
gradient.
9.
Yeah.
And gradient transpose will be used.
Basically, we are finding out this one, del F dot product with this U hat, right? This is my directional derivative. But the dot product can be, so if you find out the dot product, if you wanted to find it out the dot product, right? We generally do in vector format, like we have to take the transpose, right? Because dot product is a scalar quantity. If you learn, I don't know whether you have come across those two products about between the vectors. There is one dot product and another one is vector product, right? Or cross product. So dot product is always gives me a scalar quantity, and the vector product or cross product gives me the vector quantity. So when I say dot product, either this can be written as del F dot U, right? Or this basically shows the direction, or I have to take the transpose of one vector and multiply with another. Okay. So yeah, here it will be, what is, how much it is? 12 by.
And U is the unit vector. To calculate the unit vector.
Plus 18 by root 5.
We normalize it.
Correct.
Okay.
30 by root 5.
30 by root 5. So 30 I can write it as 6 into 5. Further I can write it as 6 into root 5 into root 5. So the root 5 will be cancelled and I'll be remained with 6 root 5. So the final answer of the this directional derivative is this. Always remember that directional derivative should be a scalar quantity, right? It shows like how much my gradient is, flowing into the direction. Okay.
Inclination.
So for the previous question, compute the directional derivative. Okay, so I think this you can do. This is the same function it is given. Only what is the difference here? Direction is different, right?
Different.
and what you have to do, 2 by root 5 and 1 by root 5 basically. So same gradient, you just have to multiply with this. That should be your answer, right? So then it will become 24 plus 9 is
9.
24 plus 9 is how much?
33.
33 root 5 should be the answer for this question. Okay, maybe I'll skip this one because it is the same question. Fine. Which direction the derivative is maximum? This maybe I'll solve. Which is the direction where the derivative is maximum? Directional derivative is maximum in the same direction in which the gradient is there, right? That will be the direction where this gradient is maximum. That's okay, right? That's okay?
Yes, sir.
Yes, sir.
So the maximum directional derivative will be del f transpose whatever I written is correct. Fine. And what is del f here? It is 12, 9. And if I use this, this will become 12, 9. Okay, what is the length of this? It's root of 12 square plus 9 square.
9 square.
So 144 plus 81. I think it is root of 225, which is 15.
15.
Right. So basically my del f upon this will become 12 by 15 and 9 by 15. And that is 3, 4, 4 and 4 by 5 and 3 by 5. Okay. So the maximum directional derivative will be 12, 9, and here it is multiplied with this. Okay. This is so 48 plus 27 is 55, 75 by 5, which is 15. So 15 is the maximum directional derivative. Okay, just look at it. Okay, once if any doubts are there, let me know.
Sir, could you go down?
Same thing we have used. Whatever we have used for directional derivative, the only difference here is we are saying that the maximum direction is in the direction of gradient, right? Previously, what we used to do, we used to have different directions, right? So there was a direction 2, 1, another direction was what 1, 2, right? We are just saying that the gradient is flowing, the maximum gradient will get it in the direction of the gradient itself. That is the only thing.
Okay, sir.
Is that okay?
Yes, sir.
Yes, sir.
Any doubts, others? Okay. Okay. What is the maximum? I think we have found out the value, right? What is the maximum value?
Sir, what is the difference between maximum and maximum?
No, it's I think that is a same thing, right? Okay. Anyway, that is so which direction is the derivative maximum? What is the answer for this question?
Gradient.
Yeah, but what is the answer for this question? What is the direction? If I ask you the question, like, can you tell me which direction is the derivative maximum? What
The
is
function itself.
4 by 5,
No,
3 by 5.
this one, yeah. This is the direction in which directional derivative is maximum. Okay. And what is the value of maximum directional derivative? That is the next question.
3 root 5.
And that should be the answer is 15.
15.
Is that okay?
Yes, sir.
Yes, sir.
You understand the difference between the direction in which the derivative is maximum and what is the maximum value of the directional derivative. Okay?
Yes, sir.
It is along the direction of the directional derivative.
Yes. What is the you know, right? Like
Cos theta will be cos. It will be cos 0, no?
Huh?
That is why it will be 1.
Correct. If you know that part, so I'm not just dealing with that part, but yeah, that's correct only.
Okay.
Because what is a dot product? Basically, dot product is let's say dot product between two vectors A and B. What is the definition? A into B
cos theta.
Cos of angle, right, between those two vectors. So if
AB cos theta.
Yeah, AB cos theta, and if the direction is same, right, then
Cos
only we'll
zero.
get there. So but then
Theta will be 0.
But what does that mean? That
1.
means A and B are in the same direction, right?
Same direction.
That is the thing.
Theta is 0.
Yeah, and that is always the maximum value, right? No, because if you take the values, what is the cos function? Here cos function actually controls the value of this function, right? So when the angle increases between two vectors, what happens? The value AB into cos theta decreases. Is that correct? Because cos theta is maximum at x equals to 0 and it is minimum at x equals to 90. And further also it is like it goes into the negative direction, right? So when you have both the direction in the same side, right? So both the vectors are in along the same direction, you have the value maximum. But what does that mean is both vectors are on the same line or same direction. And when we find out the gradient, what is gradient tells us? So if any curve is there or any surface is there, what is the gradient? It's a differentiation, right? Like along that point. So basically it is the
gradient is the rate of change of
correct
along that along
kind of a slope,
x y direction or
right,
whatever direction we are giving. Is it so?
Yeah, correct. So that is a slope, na? So suppose you have the function like this. So if I ask you what is the derivative at this point, so what does that mean is you just find out the slope, and slope basically goes like this, right? Is that correct?
If it is a linear function, then it is a straight line.
Straight line.
If it is a plane,
yeah,
then the tangent is also a plane. Is it?
No. If it depends on surface or like how we are going, right? So how you are going in the more dimensions.
Surface.
Yeah. So
if it is a surface, then tangent is a plane. Is it?
Correct. So this is in the 2 dimensions, right? Basically. So when we go above 2 dimensions, also I can not say because it is x here, and this f of x here. So only the 1 dimension, right? So okay, I will not like go into details because it will take a lot of time to maybe I will explain this. But the broader level idea is gradient is the direction in which your directional derivative is maximum. And why it is so? Because that is the direction and we are taking the dot product anyway to find out the values. So that's how to solve this part. Can we use the same thing?
Yes, just changing the unit vector.
Unit vector is what then in this case?
Minus 4 by 5, minus 3 by 5.
Correct. Minus 4 by 5, minus 3 by 5. And you will take the dot product with what? Gradient of f.
12, 9.
12, 9. And that should be your answer, right? I think that's it. Maybe there are 2 more slides are there. I will not maybe discuss this in detail. This is Cauchy. It is related to Cauchy-Schwarz inequality. This is not very important for you as of now. I guess this is like a very small topic. Generally, I won't discuss it in the sessions. You may talk to the TA, right? So he will explain it about it. But what should be the answer here? Can you just tell by looking at it? Is this equation correct? How will you say that? This is what is Cauchy-Schwarz inequality?
Dot product is less than equal to the
So
product
the
of
dot
norms.
product should be less than equals to
Product of norms.
Norms or
Negative of them.
negative of them. All right. Okay. But when this will be equal, so A transpose B will equal to this. This is happens when it is a geometrical thing, right? So you don't have to worry about right now, but this will happen when when A is some function of, so and alpha is a scalar, right? If this is possible, what does that mean? Let's say A equals to 2B, A equals to 3B. If this perfect, or maybe I can say A equals to 1.5B also. If this is there, then they are equal, right? So now you look at it and just tell me whether this is fine or not.
Yeah, they are fine. It's a scaled version of x.
So 2, 5, 6 is, and what is the scalar?
8.
8, right? So y can be written as 8 times x. So if it is fine, then this equality holds or not?
Holds.
Yeah, that is the answer. Fine. If
Sir,
you want
I'm not getting.
Okay.
One second, sir. One second.
Yeah, I'll show you this one first. This is Cauchy-Schwarz inequality. I don't know the spelling. Maybe it's like this. What it says is the dot product between any two vectors, it will be like, it is maximum, like, or what it gives me, the lower limit, right? Or upper limit, maybe I can say. Yeah, upper limit when they are positive, or maybe the lower limit when they are negative, some direction. It is actually a directions thing, but when it is going to be equal to this, or when it is going to be equal to this also, the length of the multiplication between the length, when they are the scalars of A and B, or A can be written as this, what I call it, I can't say the linear combination. What I should say is some scaled version of another vector. Fine. So in this case, if I say that this dot product between x and y, these two vectors, can it be equal to the length of x and y? So the answer to, without computing, we have to tell, and it can be said by using the Cauchy-Schwarz inequality, that is, it is true. Why? Because y, right here, y is 16, 40 and 48. If I say that, I can write y as 8 times x. What is x? 2, 5 and
Okay.
6, right? So 2, 5, 6, when I say that, it is 16, 40 and 48. That means I can write y equals to 8 times x.
This is
This
the
is
same
Cauchy-Schwarz.
as
This is
cos 0.
Cauchy equality.
Yeah. Means
Basically,
like,
cos 0, so it will become 1.
yeah, because they are on the same line, right? So that means if I just multiply their lengths, I'll get the dot product between them. Correct, na? Because you see, what is the dot product between two vectors? A dot B is A B
Cos theta.
into cos theta. If these two vectors A and B are on the same line, then what will happen?
Theta is 0, correct. Theta is
yeah, theta will be 0, and then this will become theta will be 0 degrees, and then cos theta will become cos 1. So then A dot
Correct.
B, so that is A transpose B will be this thing, right?
Correct.
Correct. And if any other angle is there, what does that mean then? Then this dot product will always be lesser than the,
Yeah.
that is what it is
Because
saying.
value of cos theta will be always less than.
Correct, na? That is what, like, it's nothing different. It's the same thing. Fine, right? And this happens between when? This happens when theta is between 0 degrees to 90.
90
If
degrees,
it
yeah.
goes beyond 90, then what will happen? Only the sign will change, na? So,
Mhm.
and due to that, this inequality will be changing like this. And that is what shown here, this part. Right? That's fine?
Yes, sir.
No doubts here, na? So what is the maximum value of the dot product between any two vectors?
The norm products.
Correct. So that means the length, the product of the lengths of those two vectors. Correct? That.
Yes, sir.
I hope that is fine to all of you. Yeah, that's it. Okay, if you want to write any answers to this, it's fine. Otherwise, it's okay. So I hope you enjoyed this session. So maybe we'll meet next week again. So just, I think we are going into the linear algebra portion from next week. So just be prepared. Yeah. Okay.
Okay, thanks.
Thank you, sir. Thank you, sir.
Okay, sir. Thank you, sir.
Okay, sir.
Thank
Thank
you,
you.
sir.
Thank you.
It was a nice session. Thank you.
Thank you.